Bright Tuty. Every student matters.
The first question is, use Mendeleev's periodic table to predict the formulae of the oxides of the following elements. Now, if you see the Mendeleev's table in your book or in the chapter or in the lesson, then you will see that in the Mendeleev's period there is a formula given for oxide. So, there is a general formula given for oxide with each group. You can see them here. So, what you have to do is you just have to identify which is the group in which the element lies, and then you will know the general formula for that particular element. So, for the first thing we have K. K is potassium. We see that K is here and the general formula is K2O. So, the compound becomes K2O, and that is because the valency of oxygen is 2 and the valency of potassium is 1. The second element is carbon. So, we move on to the group containing carbon. You see carbon is here, and again here also the valency is 2, it forms CO2. Now, this is formed by covalent sharing of bonds, and it is, even though it looks even though it is not mentioned here, but it is a covalent compound, and you will study this when you do your chapter carbon. So, the general formula was RO2, and that is why we have CO2. Next is aluminium. So, we find aluminium and the general formula is A2O3. So, Al2O3. R2O3. So, we take this formula and instead of R we write the element which we are talking about, which is aluminium. So, we get Al2O3. Next is the formula of silicon. So, again silicon also lies in the same group as carbon, and that is why it would show the same structure, SiO2, same as CO2. Then is barium. So, you see barium is here and barium is in the group RO. So, the structure of barium would be BaO. That is because the valency of barium is 2 and the valency of oxygen is also 2, and which cancels out one another, and hence we get the compound of RO type, and this we get barium oxide as BaO. So, what we have understood here is that there is in the Mendeleev's periodic classification, we already have the structure of the oxide. We just have to replace the R with the element that we are choosing from that particular group, and we will have the formula of the oxide. So, moving on, let us do the next question. Besides gallium, which other element have since been discovered that were left by Mendeleev in his periodic table of classification? So, the answer we have is germanium and scandium. Many elements were discovered after Mendeleev's period, 2 of which are germanium and scandium. You can remember any 2. The next question is, what were the criteria used by Mendeleev in creating periodic table? Now, you know that the main difference between Mendeleev's periodic classification and the modern periodic classification that you will do in the next one is the criteria that they choose. So, Mendeleev chose atomic mass as his main criteria. Atomic mass is the number of subatomic particles, that is neutrons and protons, present inside the nucleus of a given atom. So, he chose atomic mass of the element as the unique criteria for classification. He proposed that chemical properties of elements are a periodic function of their atomic mass. Although when you study further, you will realize that actually it should have been atomic number. It is a better suited way of classifying elements, but for Mendeleev he chose atomic mass, which is the number of protons and neutrons present inside the nucleus. Thus, he arranged the elements in increasing order of their atomic mass. Last question is, why do you think are noble gases placed in a separate group? Now, the answer on itself is very clear, that noble gases are noble because they do not react with any element. They do not react with oxygen, water, or any atmospheric compound easily. It is because that they have a stable octet. Their outermost shell is always completely filled, and that is why they are inert. Inert means they will not react with anything around them. And because they have this unique property, this unique nature of not reacting with anything, they are placed in a separate group of fully filled outermost shells, and that shell is called, that group is called as the group of noble gases. So, noble gases are all inert, and all of them show similar properties of no reactivity or low reactivity sometimes. Thus, they have unique properties compared to other elements, and thus are placed in a separate group in periodic table. So, that's all for this part. Thank you.